right, so we're working on 6.5 right now. We're talking about the law of sines. What we're going to do here, guys, is first, in general, a triangle is determined by 3 of its 6 parts. Okay, so we have a triangle. Okay, the 6 parts of a triangle are the sides, 1, 2, 3, but also the angles corresponding to opposite those sides. So if I decide that this is an angle A, B, and C, a triangle is completely determined by what angle this is, what angle that is, what angle is. It's 3 angles and it's 3 sides. How long that is, how long that is, and how long that is. Okay. Now, if we know 3 of those parts, okay, if we know 3 of those parts, we can get the other 3, as long as one of them that we know is a side. If we're just given 3 angles, there are infinitely many triangles that satisfy. They have the same angles because they're similar, right? For example, this is a 30, 60, 90 triangle, but that's also a 30, 60, 90 triangle here. Okay, so we have an infinite number of 30, 60, 90 triangles. They all share the same lengths of, or measures of angles. However, if you have one side, there's only one triangle that has, say, a side and then 2 other pieces to it. So that's one case that we don't have. Is if we have to have a side when we go through a triangle, we can determine all the rest of the parts. So case 1 is if we have an angle, a side and an angle, or similarly side angle, we can determine all the rest of the parts. If we have 2 sides in an angle, we can determine all the rest of the parts. If we have side angle side, we can determine all the rest of the parts. And if we have side side side, we can determine all the rest of the parts. What does this mean, angle side angle? So suppose we know, grab another pen here. Suppose we know this angle, the measure of this length, and this angle. So angle, side, angle. Then we can determine all the rest of the parts. We can figure out the length of this, we can figure out the length of this, we can figure out this measure. Okay. In addition, suppose we know 2 sides and an angle. Suppose we know, say, this side, and then this angle. Okay, in that order, side, side, angle. We can also determine the rest of the parts. And we can do that similarly if we have side, angle, side, if we have a side and the angle in between those 2 sides. And if we know all 3 of the sides, then we know all the rest of the parts of the angle. Okay, how do we do this? Well, we use the law of sines, okay? What's the law of sine say? The law of sine says in a triangle, ABC, okay, so ABC, okay, we know that's the ratio of sine of A to A, okay, the ratio of, let me erase this, the ratio of sine of A to A is equal to the ratio of sine of B to B, which is equal to the ratio of sine of C to C. This is the rule. Now, why is this true? Well, if we have a height here, h, we know that we can measure the area of this triangle. We've talked about this before. The area of the triangle is 1/2 A times B sine theta, right? A, B, sine theta. But we can also say it's where theta is AB sine of C, where this is C. We'd also say that the area of the triangle is also 1/2 A times C sine of that angle B. But we can also say this area of the same triangle is equal to 1/2, okay, B times C sine of A. So all 3 of these things are equal to each other, okay? If all 3 of those things are equal to each other, then we can set this equal to this, equal to this, okay? So let's have a little 3-pronged ratio here. 1/2 AB sine of C equals 1/2 AC sine of B, which equals 1/2 BC sine of A. If I multiply everything by 2 and divide everything by ABC, I'll get sine of C divided by C equals sine of B divided by B equals sine of A divided by A, and that's precisely what that says. So now we have the law of sines, which says the ratio of sine of an angle to its the side opposite to it, length of the side opposite, is equal to the sine of a different angle, side measure of the side opposite it, is equal to the sine of the angle C divided by the measure of the side opposite to it. Okay? Okay, so now suppose I have an example. I want to solve this triangle here, okay? I want to solve this triangle. I've got two angles and the side in between them. So what I have here is I have angle, side, angle. So if I want to figure out how to solve this, what I do is I go sine of 52 degrees is to this measure, we'll call this little a. Why do I call it little a? Because it's opposite the angle. A is to A as, now let me ask you, if we know this angle and this angle, do we automatically know this one? I say we do, because the sum of all the angles in a triangle must equal 180. So we know that this measure here must be 180 minus the sum of 52 plus 70, which turns out to equal, I think if you do 132, 180 minus 132, I think is 48. Okay, so I have 48 degrees right here. This is 48 degrees. So sine of A is to this as sine of 48 degrees is to 26.7. Okay. So the sine of this angle is to this measure as sine of this angle is to this measure. Okay. So again, you can multiply both sides to get rid of your fractions here. So we'll have, and then solve for A. So we'll have sine of 52 degrees. Okay. Divided by sine of 48 degrees times 26.7 will equal A. And I think if I do the math there, I think I get 52 sine of that divided by parentheses 48 sine equals times 26.7. I think I get A equals, I think I got 28.3-ish. Okay, 28.3 is the measure of A. All right, fine. But I can also use this same ratio. Sine of 48 degrees is 26.7 as sine of 70 is to some unknown value B. Okay? So again, multiply by B over there. And then over here, I have what? Sine of 70 degrees divided by sine of 48 degrees times 26.7. And let's see what I get there. If I get all that, 70, let's do that. 48 sine over x times 70 sine equals times 26.7. I think I get 33.76. We'll call it 33.7. Close enough. Okay. All right. So that's using the law of sines. So now I've determined I had three parts, 1, 2, 3, and I determined the other three parts of the triangle, 1, 2, 3. Determine that angle, which is quite easy. I got those using the law of sines. Okay, so the first two cases that we have, angle, side angle, and side, side angle, those two cases are we use for the law of sines. The first one is the easy one. We just looked at an example of that one. Okay, angle, side angle, or side angle, angle, which is equivalent. That's the easy case. Case 2 is considered what we call the ambiguous case, and the reason for that is, and that's case 2 is that side, side angle. The reason for that is you could have a situation where two triangles solve it. Okay, here's two triangles solving it. You could have a situation where one triangle solves it, and you could have a situation where no triangle solve it. Well, what do I mean by that? Again, we're given two sides of a triangle and an angle. So we give it a side, then an angle. What happens if I'm given a side that has this length, a side that has this length, and an angle measure? This angle is too big. It doesn't go all the way back to here. This is a zero solution case. That could happen. But we could also have a length A and a length B, and we have an angle measure, and it hits right where that thing ends, and that's a one solution case. That works great. We also have a situation where, suppose we have a side, and then an angle. Well, what happens is there could be two cases. The length of this length right here, because this is, I think of this as like an isosceles type deal, where this length is the measure of this. Notice that this length of this B solves this triangle because I have a side A, side B, and then an angle. But also this triangle will have a side A, side B, and then, oops, that's not B, and then a much larger distance. So this could be C could solve it, or we'll call that C star could solve it. Each one of these measures could solve this triangle. So this is a two-case situation. So what we're going to do is we're going to look at the ambiguous case, and we'll look at the different triangles that we could have in that situation.